Hello children, let's continue with chapter number 3, Understanding Quadrilaterals of Standard 8th. We have already studied about the types of quadrilateral. Now we are going to use the properties to solve certain examples. Here you have been given a parallelogram ABCD. The question is, complete each statement along with the definition or property used. So this is your quadrilateral ABCD. The diagonals are also shown which are intersecting at the point O. Now the statements are given and you have to complete the statements. Moreover, you have to tell the definition or the property whichever you have used. Now the very first is AD, which is equal to, obviously it is equal to BC. The reason is they are the opposite sides of a parallelogram and the length of the opposite sides of the parallelogram are always equal. The next one, angle DCB is equal to, so we can easily identify that angle DCB is equal to angle DAB. The reason is opposite sides of a parallelogram, opposite angles of a parallelogram are equal. The next one, OC is equal to. Now, we already studied about a property of parallelogram wherein the diagonals of the parallelogram bisect each other. The same is here. Here we are told that OC is equal to which part? So it is actually equal to OA, and the reason is diagonals bisect each other. Then comes the next sub question. M stands for measure of. Measure of angle DAB plus measure of angle CDA is equal to dash. So, in the blank, you are going to put it as 180 degrees. The reason is both the angles, that is angle DAB and angle CDA, form a pair of co-interior angles. They are also the adjacent angles of a parallelogram. The property goes as the adjacent angles of a parallelogram are supplementary. So, we are going to note it down. With this, let's proceed ahead. Consider the following parallelogram. Find the values of the unknowns. Now here, if we look at the figure, it's a parallelogram with one measure known to us, that is 100 degrees. The other three are represented by X, Y and Z, and we are supposed to find the measure of the three angles. Let us start with the solution. Here, the easiest one is finding out Y, which is opposite angle of the parallelogram, and we all know that opposite angles of a parallelogram are equal. So, measure of Y will be equal to 100 degrees. The next step goes as x plus 100 degree is equal to 180. Now, if we look into the parallelogram, you will see that x plus 100, they form the adjacent angles of a parallelogram. And we all know that the adjacent angles of a parallelogram add up to 180. That is, they are supplementary. We further solve it to get the value of x, which is nothing but equal to 80 degree. Now once x is known to us, it is very easy to find out z, because z and x are opposite angles of the parallelogram and they are always equal. So z also comes out to be 80 degrees. Let's proceed with the next sub question. Again, one angle is given, that is 50 degree. X, Y are the interior angles of the parallelogram, whereas Z is one of the exterior angles. But we have already studied about the properties of exterior angles also. There are certain other pair of angles that also can be used here. Let us begin with finding x initially. X and 50 are the adjacent angles of the parallelogram. So their sum is 180. When we solve it, we get the value of x, which is 130 degree. Now, if x is equal to 130 degree, then y also will be equal to 130 degree because they are the opposite angles of the parallelogram. Now, if we talk about z and x, they are forming a pair of corresponding angles. Here, this is one line, this is another line parallel, and this is the transversal. So, we can say that angle x and angle z, they are the corresponding angles. We also know that when the lines are parallel, the corresponding angles are equal. So, we will say that z is also equal to 130 degrees. With this, we proceed further. Again, one angle is known to us, that is 30 degree. It is actually 30 degrees. It's not 3, it's 30 degrees. Moreover, by using the vertically opposite angle property, we can say that x is equal to 90 degree. Here, this is 90 and this, they are vertically opposite angles. So, we conclude that x is equal to 90 degrees. Now, we can proceed further. Here x plus y plus 30 degree is equal to 180 degree. Actually, we are talking about this triangle. In this triangle, two measures are known. We have to find out the third measure. So, we are using the property of angle sum of a triangle, and we can proceed further to find out y. Y comes out to be 60 degrees. Now, we are supposed to find out z. Now, we can say that y is equal to z. The reason is this line and this line are the parallels, and this can be considered as one transversal. In that case, angle y and angle z are the alternate interior angles, and we all know if the lines are parallel, then alternate interior angles are equal. So, we can conclude that y is equal to z. The reason is alternate interior angles. So, we can further state that z is equal to 60 degrees. One more example to go. Here one measure is given, that is 80 degree, the rest 3 to be found. We can find out x because x and 80 form the adjacent angles of a parallelogram. They add up to 180, that is, they are supplementary angles. When we solve it, we get x equal to 100 degrees. The next is y equal to 80 degrees because y and 80 are opposite angles of a parallelogram which are always equal. Regarding y and z, we can say that they are alternate interior angles. Here we have considered this and this to be parallel lines and this one as the transversal. In that case, y and z are alternate interior angles. There are other methods of finding z also. You can proceed with any of the correct methods. So, we say that z is equal to 80 degrees. Another example. Here you will see that two angles are given and we have to find out other three. Let's begin with the easiest one, that is y equal to 112, because these two are opposite angles of the parallelogram and they are always equal. Regarding z, z plus 40 plus 112 is equal to 180. The reason is adjacent angles of a parallelogram, they are supplementary. Here we are considering this angle and this angle. They are adjacent angles of the given parallelogram, therefore they add up to 180 degrees. We can easily solve and get the value of z, which comes out to be 28 degrees. Regarding x and z, they are equal because we consider these two parallel lines and this one as the transversal. So z and x are alternate interior angles and they are equal. That's why we conclude that x is equal to z, which is equal to 28 degrees. With this, we come to the end of few topics. We'll be continuing later on. Goodbye for now. Thank you.